Alright, let's get started with um, continuing with transformations. With 7C, we're going to look at combining two transformations together. So for example, here we have we have a dilation of factor 2. So at the same time, with the rule, what you do is you do a mapping of coordinates. You start with the original coordinates x and y, and then you do the dilation of factor 2 from the x-axis, meaning the y gets multiplied by 2, so we get a new set of coordinates. And then the reflection in the x-axis, therefore the y component gets turned into its opposite. So we started with 2y in the middle, and we end up with negative 2y. If we apply that to a pair of numerical coordinates, we get those following values. Then here is a different example. So we apply a dilation of factor 2 from the x-axis, so it becomes 2y, similar to that next one. Then what we do is we apply a translation of 2 units in the positive direction of the x-axis, meaning we add plus 2 to the x component from the previous coordinates, and then 3 units in the negative direction of the y-axis, so it's a minus 3 to the y component. And here's the example by substituting values, which is handy as you can indicate on the Cartesian plane the transformation arrow. So it will show you which direction the curve is moving to. It's just in case it helps you to visualize it. Okay, let's look at an example with the square root function. So you have two parts with two different sets of transformation. Let's look at the first one. So with the first one, what you do is you apply the transformations in order by doing the mapping. Okay, and then what you do is with the last one, which is the new part, you make it equal respectively to x prime and y prime. So you write your two mapping equations, then you rearrange to make x and y the subject instead, and what you do with those, you substitute back into the original rule. That will give you the new rule, and you make y prime the subject, and then you just remove the y primes, the primes. The new rule will be y equals negative 2 square root of x. Okay, with part B, you do again, you follow the rule, then from the last one you write your mapping equations, you rearrange to make x and y the subject. Just be careful when you do that. You need to do your auto operation and your transposition properly. You substitute back into the original rule, and you make y prime the subject to get the final rule. Okay, so to summarize, you have a series of transformation. You describe the rule in successive steps, do them in order. So you start with the dilation, translations, a reflection. So you have your dilation, your translations at the same time. As they apply to different variables, you can do them at the same time. And then your reflection. You write your mapping equations, you rearrange them to make x and y the subject, you substitute into your curve. So here is y equals f of x. You substitute your x and y, and then you make y prime the subject. So the last equation that we have down here, what they jump the step a bit, is what you should have originally, having your y prime and x prime inside here. They remove the prime to that equation to get the transform curve, or the rule of the transform curve. And that's pretty much it for determining the rules of the combined transformations. Alright, 7D is going backwards. They will give you the rule, and you need to determine all the transformations in order. Generally, they will give you will get the rule of the original function. So here it's y equals square root of x, and then you will have the rule of the transform function in terms of, if it's not x prime y prime, what you need to do is add the primes. Then you need to kind of rearrange it to make square root the subject here. So square root on the right hand side looks very similar to the square root of the original. So what they did is they divide by -2. Then what they do, they map the left hand side and the right hand side respectively. So the left hand side, you will have your y and y primes, so that will be your second equation. And the right hand side, under the square root, you have x and x prime. You make them respectively equal, which this one won't change. That one will change, the second one, because you want to make x you want x prime from the first equation, but also y prime from the second equation to be the subject. And then what you do, you use your order of operation to read out the transformation. So here there's a -2 in front of the y. That tells us that it is a dilation of factor 2 from the x-axis. Also, the negative tells us it's a reflection in the x-axis. You can apply those two in different orders, like you could have the reflection first and then the dilation after, as it would not change the order of operation. Like the result will be the same. Another method is to use inspection. This is a kind of method that is you will do in year 11, but in year 12 the mapping is the most effective and reliable method if you deal with, let's say, 3 or more transformations. And also you will have a combination that will apply to the x-axis, along the x-axis and the y-axis, that might be a little bit more complicated. Alright, so let's look at this example. With the first method, we'll use inspection. So looking by inspection, you have a dilation of factor 2 from the x-axis, and you have true translation. This one is 2 units in the positive direction of the x-axis, and here it's 3 units in the positive direction of the y-axis. You'll tend to learn that from reinforcement, that if you have a negative here, it's to the right, but the mapping of coordinates is justifying, and you can't make a mistake if you do the mapping method. So let's move on to that one. So you look at your equation here, which is your transform equation. You would add your prime to the x and y. You link the mapping between the y equals x squared to y prime and so on. Wait, I'm trying to get my laser back. Alright, you will rearrange this equation to make the bracket squared to the right hand side. So we have that bracket square, we do a -3 and we divide by 2. What happens is this bit now is very similar to the original x squared. So by mapping the left hand side and the expressions under the squared, we get those two relations. We make x prime and y prime the subject, which what we have here, and then we can read out the transformation. So on the direction of the x-axis, we have a translation of 2 units in the positive direction, and which will be applied at the same time as the y1, because what you apply to the x variable is independent from the y variable. But when you look at the y expression, you can see that from your bond mass, you multiply by 2 and then you add 3. So the dilation of factor 2 comes first, followed by the +3 and the +2. We can apply the translations at the same time. Alright, with part B, you have the original curve and the transform or the image rule. We rearrange that one to make, there's no rearrangement, there's already a y prime and x prime, there's a square root and a square root. We map the left hand side. On the right hand side, under the square root, we map the x and the 5x prime minus 2. We rearrange or solve for x prime and y prime. Now notice the way they're separated. As you separate it, you can change your order of operation. If you keep it that way, we'll translate first and then dilate by a factor 1/5. If you separate it into two separate fractions, you change the order. You will have your dilation first and then a translation of 2/5. So it doesn't matter which expression you use. In this example, they separated and they used the last expression. Therefore, they get the dilation of factor 1/5 first from the y-axis, and then a translation of 2/5 units in the positive direction of the x-axis. So that's using this expression. You could use that one instead. Okay, another example. This one is a truncus, which is your original truncus. Here is a transform 1. You will there's another example, but you map hang on, sorry, that's the other way around. So this is the original function and that's the transform 1. So as it is a transform 1, we apply the prime to those ones. We rearrange that one to make sort of reveal the 1/x squared on the right hand side. We equate the expressions and rearrange to make y prime and x prime the subjects, and we read out the transformation. Notice how from the previous example they don't separate the fractions, which is fine. You can leave it that way. It means that you will have your translation first of 6 units in the negative direction of the y-axis, followed by a dilation of factor 1/3 in the x-axis. But they combine the two translations together because they apply to separate variables. So to the x variable, or to the in the direction of the x-axis, you will have a translation of 1 unit in the negative direction of the x-axis. So the -6 and the -1 are combined together as two translations, again because they apply to two different variables, so they combine them together. Then for example B, so you start with that's your starting graph, that's your image graph. So let's look at the solution. You would just hold on. All right. So with that original equation, this one, you make the prime to the y and the x. Hang on, my bad again, sorry, my apology. This is the original function, so we don't touch it. The image one, this one, that's where we put the x prime, y prime. That's the image one. With the original one, you're going to rearrange it to make the, see there's a square here, we need to make that square the subject. Okay, so we just minus 6 to the y. That's what we get down here. We equate the left hand side and the right. So the right hand side is under a square, so we ignore the square, we just equate the expression under the square, and we'll get our respective equation. We rearrange to make, hang on, I lost my cursor. Where's my cursor? Oh, here. As we equate the equation, we make the x prime and y prime the subject, and then we can read out the transformations. The minus 6 and the minus 1 can be done together. So we start with the dilation of factor 5 from the y-axis, and then we have the two translation. So because we like to do x and y in order, it's a dilation of 1 unit in a negative direction of the x-axis, and then a translation of 6 units in the negative direction of the y-axis. Okay, and that's it for 7C and 7D, and I'll see you next time.